Hello and welcome back to a rather hot and sweaty London. It's about 35 degrees here, so if I look a little bit more shiny than normal today, then I apologise. But let's get on to Sonic. So, last video, if you remember, we had it kind of running on hardware, but it wasn't really running very well at all. As soon as I enabled sprites, the screen flashed because we were trying to do too much in a single frame. So, to remedy that, over the last month, I've been doing optimizations. Optimization 1 was sprite caching. Optimization 2 was changing how Sonic's tiles are unpacked in memory. Optimization 3 was playfield restoration. And optimization 4 was double buffering. We'll talk about all of these in detail later, but I figured we'd just start by showing how it was running. And it's running a lot better than it was last month. However, I would be lying if I said I was really pleased about how it was running. It is alternating between the full 50 frames a second and 25 at the moment. So it's a lot better than last month when it wasn't running at all. However, there's still quite a long way to go just with performance. And part of the reason why this is quite slow at the moment is because we're using chip memory and we have to be very careful about moving data around and the number of blits that we're doing. So even with the limited number of sprites and scrolling that we've got going on at the moment, it's still quite slow. Then again, I think this is probably the first time that Sonic has ever really been run natively on an Amiga without emulation, so that's something, and we are making good progress. So, and it is actually running on hardware, so that's a start too. The priorities aren't in yet, that's a job for another day, but you can see the game is kind of coming together a little bit more than last month now. And this isn't through want of trying. You know, there's a huge amount of work that's gone into this last month of optimizations, but it's still not fast enough. And you can see there's a few bugs, like just then the screen flickered and flashed. I don't quite know why that is yet. It might well be that I'm doing something naughty, like a register write in the wrong place, or my timing of certain operations is just a little bit wrong. So what I thought we'd do now is actually see how we can get a new object into the world of Sonic. In the last video I mentioned that we were going to try and do this, and I feel that we're spending an awful lot of time optimizing, which is absolutely essential, but I kind of want to show that this process isn't actually that difficult, so that all the work I'm doing towards optimization is for a reason, because a lot of this should just fall into place. So what I've got up on screen right now is the Flex sprite editor for Sonic. It's a slightly hacked, modified version I made for Rick, so it works with a 32 color palette. In the game world, I'll get up Sonic LVL. You can see here they are, you know, placed around. You can drag them and stuff, etc. Very cool. I mean, one of the most simple objects, so what can go wrong? Let's start with one of the files that Rick has sent me. It's called spikes.bin, and spikes.bin effectively is the output that you just saw from the Flex level editor here. The first thing I actually want to do is just verify its contents after it's exported from the editor before we even get it into Engine. There is another file that I've already copied into this directory, and that is this spikes.asm, short for assembler, obviously. That came from the Sonic disassembly that already exists on the internet. So if you go into the maps folder, there's a file here called spikes.asm. Right, there we are. Now, if you look at what is in this file, and we'll just open it up here, zoom in a little bit. Really what this is, it's a bunch of frames that are specified, frame 1, frame 2, frame 3, and each one of these has got sprite pieces in. So that's like a Mega Drive style sprite. And you can see 3 spikes is commented there. 3 spikes facing sideways, 1 spike, very helpfully commented by someone, not me. And then if you look here, yeah, look, that aligns, right? So we've got 3 spikes facing sideways, 1 spike, etc. Okay, cool. So this file is really saying how should the sprites be laid out. So an object is multiple sprites. A sprite piece here denotes a single sprite. So we've got almost a config file for this object, and we've got the raw data itself. The next thing we need is an Amiga palette. We've already got that set up. However, this assembly file that you can see here is in a S assembler format, and it won't work with VASM, which is what I'm using on the Amiga. So there actually just needs to be a little bit of a conversion run to convert this file to the format of VASM, and then we're going to write that out to out/spikes.asm. So let's see if this works. Okay, apparently it has. So what I'll do now is just go to my out directory and let's just drag this in here. Right, okay, so if you could compare those two files, I'm flicking between them now, you can see there's not really much difference between the two at all. It's just a small formatting convention that's needed because macros work differently in the VASM assembler to the one that was used to compile Sonic for the Mega Drive. So I had to write a conversion script. You may think, why is there a conversion script for this? Well, there's hundreds of these files, so hand editing them all would be boring. Okay, now here's where it gets interesting. So we have the three components that we need. We have a palette, we have the sprite data, and we have a converted like mapping file. Now I've got another tool, and the reason I've got this extra tool is because without it I was finding that often I was picking up errors in the data too late, and then I would be wondering, is this an engine bug somewhere in my code, or is it a data bug, a format bug with the palette or something like that? So I wrote another tool to handle this. Now this tool has a conversion file. We've got a config entry, and the config entry is for the spikes, and it's saying here is the mapping file used. That is the converted assembly map that we just wrote out, and I've got Rick's palettes loaded in here as well. There's two palettes. There's a Green Hill Zone palette, and there's a palette that's specific for Sonic and the sprites, and I've kind of mapped them together and said where the colors go in memory. Here we have the actual spikes graphic as well. Now that group that I just specified there called spikes, if I then run this and give it the argument spikes, it should output a PNG file that shows the content of these three files that are needed after all the conversion and everything else. I think that worked. All right, so we go to the out directory and let's load up the image that's created. All right, here we go. I'm just going to make this bigger so you can see it. So in here, now this is using the new Amiga data. So it's showing the palette that I've mapped in. It's showing how the spikes look. And you can see here a bit more beautifully than in the assembly earlier that, look, here are like these three spikes. They're three individual sprites. And it's saying here are the X and Y offsets. They're going to be plotted at it. It's telling you those sprites are 1x4. That's 8 pixels by 32 pixels each. And these are a group. And in the code itself, then you can say, okay, give me spike frame 0, which is this one, sprite frame 1, sprite frame 2, which is just a single sprite. And that's sort of how it's working under the hood. And this is just a nice visualization of that. So what we've proven now is that the data is good. The data's good, and really it's up to me now to get this into Engine. The first thing we need to do is copy over that converted mapping file that I mentioned. That's the one that looked like that. That goes into a folder in our directory structure called maps. Here we are, maps. Right, so I'm literally just going to drag that in there now it's converted. Each object like this has its own specific code file. And when Sonic was disassembled by the guys that did it, they kind of wisely extracted every object and put it in its own file. So it was kind of modular, so that I guess if you wanted to edit it or tweak the behavior of something, it was a lot easier to do with an external tool or just by yourself. So what we're going to do now is go to the disassembly of Sonic, which I've just got in the window here. We're going to go into this object directory that's here. I'm going to look for, I'm just going to search for spikes. Spikes, number 36. And then I'm just going to drag that file. I'm going to put it in our Amiga converted port. All right, there it is. It's probably not going to like work first time in terms of like the file's not going to compile. We'll check that in a minute. Include engine maps rings, no, not rings, spikes ASM. I'm also just going to include the object version as well. There are already a bunch of warnings and things like that. So the first one is this make art tile command. We don't need exactly that macro on this version. We can just do this. So that's the first change. That's basically setting the object graphics. Right, what else is wrong? Okay, we've got this line here which is saying if revision is more or less than 0. Let's just see what that's about on line 90. I think that exists and it's just because it's compiling the file on its own. Fine. It says change to 2 to build the version from Sonic Mega Collection dubbed RevXB, which fixes the infamous spike bug. Okay. Well, I'm not going to change that now, just in case there's anywhere else in the code that relies on it being 1, which is what I currently have to set it to. But we can come back to that later if it didn't get fixed until revision 2, which leave it as is for now, I think. Okay, so that's fine. Let's just see if this even compiles now. If I just run this, nope. Okay, yeah, we are missing a reference to map spike. Okay. Well, we know exactly what map spike is. Yeah, it's there, and there's no reference to it. So map spike is just a reference to the map file. Then I forgot to add it, or I didn't bother until it was needed. So here we go. Let's add one here. Map spike. Great. Okay, well, let's see what happens now. Reference to undefined symbol. Solid object. What is solid object? Maybe it's code that I haven't ported. Solid object, what are you? I don't think I've ever seen solid object before. This is exciting. This is something new. Search my code base. Yeah, it's only referenced in spikes, so we haven't come across solid object before. So let's go back to the original Sonic code base and search the whole lot of it for solid object. Here we go. Okay, 41 uses. Okay, it's a separate file here called solid object. So let's go and find that file from the original code base. Sub solid object is 8K. Maybe this is going to be more tricky than I thought. Let's copy it in. All right, solid object. Right, so this is 316 lines of code. So this is already becoming, you can see, sort of starts becoming a little more tricky. You start following a path, and where does it end? Where is it going to unravel? Don't really know. That's part of the fun. What does this even do? Solid object subroutine includes spikes, blocks, rocks, etc. Okay, so it's shared code between anything that's just a boring thing that doesn't move on screen, it seems. Okay. Right, let's compile this thing again. Have a look. Well, build error. I think I know what we need to do. So you have to be super careful when you're porting all this code, because often there are loads of gotchas to do with how memory addressing works on the Mega Drive. And I think this could be one of them. I'm just going to quickly do a quick fix for this, but it could cause all kinds of problems. I'm going to take a punt and just turn that into a long. What I'm really doing here is trying to decouple this from needing to work within 64K of memory and ensure that it can work with the full addressing space available on the Amiga. But I'm kind of just doing it super quickly. We've got a new error here. which is move Sonic on. Okay, so you can see here that I thought it was going to be simple, and we're already finding more and more code that we need to port over. Subroutine to change Sonic's position with a platform. Okay, well, I'm going to say we don't really need this because this isn't a platform. So I'm just going to comment this out for the time being. Okay, so spikes, spikes, spikes. What's going to happen this time? Okay, well, the game booted that time. It's in a bit of a chonky state at the moment, but whatever. However, I don't recall having copied the spikes graphics into the build, these new ones from Rick. I think the old Mega Drive graphics just might still be sitting in the build, so we need to do that for sure, because otherwise they're not going to display correctly. All right, copy those in. Now we're going to run it and go to debug mode and see if we can find the spikes that I was moving around with earlier in this level. So just enter debug mode and we'll fly to where the spikes are gonna be. See if the whole game crashes or what's gonna happen. Where are you, spikes? Spiky, spiky, spiky. Should they have been there? They should have been there. Where are they? Where are they? They're not there. It didn't work first time. Oh no. Well. Right, so I worked it out and I was actually looking for this file earlier and I went to the wrong one and I thought, okay, maybe I'm misremembering things. But there's a file here called object pointers, and this is a big table that points towards the objects. And you can see in this table I've got the things that are already working. So Sonic's hooked up. The TM logo on the start screen is hooked up. Rings are hooked up. But obviously if we go to spikes here, it's set to null object. So nothing's going to happen. So I just need to type the name, I believe, of the subroutine there that controls the spikes. I just jumped to it. Object 36 spikes. Let's just see if that looks similar to how rings is set up. Object 25 rings. Yeah, that's set up. Okay. So yeah, all of these are just nulled out until I implement them. You can see the huge long list of stuff. But this is one of the easier ones. I don't know how long this video is. I'm going to edit it down to about 5 minutes. But I've been going at this for a while now. Mr. Spike, are you going to spike me? All right, let's fly through the level again and see what happens. Where are they? Come on. Yes! Yes, it's some spikes. Oh. Oh my goodness. Right, come on then, let's do this. Oh, hello, Sonic. Let's see if they work. Because I did change all that code in a real rush. I've probably really broken something. I'll probably just fly through it. Oh no, hang on. Right, stop that. So that is how you implement an object in Sonic. It's really quick compared with all the optimization work I'm doing. That is, believe it or not, really easy. It's just sometimes doing these things on camera is a bit more tricky. Anyway, I hope you enjoyed that.